I'm going to use this laser setup to show how your eyes work, why you might need glasses or contacts, and what those corrective lenses are actually doing. The cornea on the front of your eye and the lens right behind that are what bend light entering your eyes. If you're looking at something really far away, like a star, your eye takes in that light and focuses it down onto a single point on your retina on the back of your eye. Your retina is where you have all the photosensors that are converting that light energy into electrical signals that your brain can understand. The lens in your eye can change its shape, causing light to be focused to different positions. This is how you can shift focus from things up close to you to things further away. While this is how your eye focuses light from something far away like a star, for something up close, really an upside down image is being formed on your retina while that focus point is happening sooner inside of your eye. But the setup that I'm showing is the easiest way to convey these ideas and then explain things like different eye conditions, how that affects your vision, and how corrective lenses work. If you have myopia, that means that you're nearsighted and your eye is focusing the light too soon. So by the time that light reaches your retina, the rays have spread out and it will be blurry. So if you're nearsighted, it will make things up close look more in focus, while things further away will be more blurry. Myopia is super common. More than 40% of adults have myopia. Hyperopia, on the other hand, is when your eye is farsighted. So your eye is trying to focus the light too late. So when the light hits your retina, it hasn't quite come to a point of focus yet. So your vision becomes more blurry. When you have hyperopia, things further away will be more in focus while things up close will be blurrier. This is rarer than myopia, with about 10% of adults having farsightedness. Now, astigmatism is weird. It means that your eye is shaped asymmetrically, so more like an oval than a circle. This causes light to be focused differently in different directions. So for example, the horizontal part of your vision could be nearsighted, while the vertical direction of your vision could be perfectly normal or farsighted. Astigmatism makes pretty much everything blurry and is why points of light like car headlights may be spread into lines at night. I don't have astigmatism, so I don't see those lines at night. Astigmatism is also really common, with around 40% of adults having it. Now that may sound really weird because I said that 40% of people have myopia, 10% have hyperopia, and now 40% have astigmatism. This is possible because a lot of people have both. Many people are overall nearsighted while also having astigmatism. Okay, so that's what can be wrong with your eyes. How do glasses and contacts fix these things? They shift the point of focus in your eyes, moving it back onto the retina where it should be. So if you're nearsighted, you need to push back that point of focus so it goes back onto your retina. To do that, you need a type of lens completely different than the ones I've been showing so far. You need a different kind of lens that spreads light out. So the lens I showed first is called a positive or plus lens, and it brings light to a point of focus, while negative or minus lenses spread light out. So if you are nearsighted, we need to push back this point of focus. Putting a negative lens in front pushes that back. This lens is actually way too powerful. It's so strong that it basically cancels out the first lens, making the light straight again. But if I had a weaker negative lens, I could move back that point of focus onto the retina where it should be. These glasses feature negative lenses for nearsightedness. So if I have a nearsighted eye and I put these frames in front of the eye, if I have it lined up right, you see that it is pushing back the point of focus. These lenses are still too powerful, pushing back the point of focus more than it should be, but it should go right onto the retina. So if you're farsighted, you need those plus or positive lenses. So for the farsighted eye, I need to move up that point of focus. So putting another positive lens in front of the eye moves it up. Again, you can see this lens is too powerful. It moved the point of focus to inside of the eye. Here it is outside of the eye. Here it is inside of the eye. But again, choosing the right lenses for your level of error moves that point of focus right onto your retina. Because the lenses for astigmatism need to correct for light differently in different directions, you can actually see that the different parts of this lens are curved differently. And with this laser demo, as I rotate a lens for astigmatism, you see that it focuses that light differently in different directions. As I rotate a lens for astigmatism, you see some weird effects and these lines turning. That's because they're focusing light differently in different directions as I move this. If you look at your glasses prescription, the first value should be a spherical or SPH specification. This describes the overall power of your lenses. If it's positive, that means that you have positive or plus lenses. And if it's negative, you have negative or minus lenses. The bigger the magnitude of this spherical specification, the worse your vision is and the stronger your lenses are. So that means that they're bending light more. If you have a value under cylinder or CYL on your prescription, that means that you have astigmatism. Similarly, this magnitude and the sign of that specification describe the strength of your astigmatism and whether you have positive or negative lenses. Your axis specification then describes the orientation of your astigmatism, so which directions have this error. Your glasses or contacts need to be oriented in the right way, otherwise they won't address your astigmatism. Laser eye surgery, like LASIK, actually changes the shape of your cornea, which can correct for a lot of these errors. I'm an optical engineer, meaning that I help people do really cool stuff with light, like helping robots see, making things like the chip that makes your cell phone so smart, and using lasers in cool ways like welding and cutting metal or laser eye surgery. And I think that bringing that background to these ideas about how your eyes work let me approach this from a bit of a different angle. Please like this video if you find this stuff as cool and interesting as I do. Thanks.